Hello and welcome to the Smoothing Tutorials series for NumXL. In this video, we'll demonstrate Brown's simple exponential smoothing function. For our example, we'll be using the monthly sales figures from a hypothetical company. Let's start now. I already have computed and plotted the simple 4-month moving average. To calculate the simple exponential smoothing function, select the E4 cell. Using the equation toolbar, type in the function name, SESMTH, and click on the FX button. In the function argument window, specify the input cell range. For the smoothing parameter alpha, let's choose 0.8 for now. For the forecast horizon, set t equals 0 for in-sample smoothing. Now click OK. The function shows us NA since we don't have enough data. Copy the cell's formula to the one in the next row. Then edit it. Change the input cell range to include all the needed points. Lock the starting cell, then click OK. Next, copy the cell formula to all the cells below it. For an out-of-sample forecast, select the last cell and copy it to the next cell below it. The returned value shows an error. This means you should edit the formula. Exclude the empty cells at the end of the cells range. Then lock the last cell in the range. To compute a forecast for more steps, copy the cell formula to the other cells below. Now we need to calculate the smoothing factor that minimizes the error between the smoothed time series and the original data. To do that, we try several values for the smoothing factors, from 0.1 to 0.9. First, we find the sum of the squared errors. We'll use the TS_sub function to compute the errors in the time series, and the SUMSQ function will help us calculate the sum of the squared errors. Now select the table, then switch to the Data tab to locate the data table. Since the values of the input variable are in one column, we set the reference cell in column input cell. Click OK. The data table computes the sum of the squared errors for all values in the table. When examining the values, the utility reaches a minimum value at 0.8. Plot the sum of the squared errors versus the smoothing factor values. It is clear that an alpha value of 0.8 gives us the best fit. That is it for now. Thank you for watching.